Our last video. This is going to be a video on mean testing using a hypothesis test. If you take a look at an example that we have here in our homework, remember that the requirements for a mean test for a hypothesis is that the population has to be normally distributed or the sample size has to be greater than 30. If we look at this example here, we're talking about video games showing violence and the duration of time that violence was shown in those video games. And here we have a set of data and what requirements must be satisfied in order to do a proper hypothesis test. Well, we don't have more than 30, and there's nothing that says anything in the description of the data that we have that it comes from a population that is normally distributed. So either the population is normally distributed or n is greater than 30. But we also have to remember that our data has to come from a simple random sample. So are these conditions met? No, they are not. The sample size is not greater than 30, and the sample does not appear to be a normally distributed population, and there's not enough information to determine whether the sample is a simple random sample. Great. Okay, so now let's look at a couple of your homework problems. Here an example of a hypothesis test. We have student evaluations and courses. There is a sample size of 86. The sample standard deviation, X bar, was 3.95 with a standard deviation of 0.67. And we want to use a 0.01 significance level to test the claim that the population of student course evaluations is a mean equal to 4. And we're going to assume that a simple random sample has been selected. We're going to identify the null, the alternative hypothesis, the test statistic, the p-value, and then we're going to state the final conclusion that addresses the original claim. So first of all, our claim is that the population is equal to 4. Our null hypothesis, again, is always equal to. Our alternative hypothesis is going to be the opposite of our claim. Our claim contains that condition of equality where it's equal to 4, and the opposite of equals is not equal to. So we're going to select option C. Now we want to determine the test statistic. So I'm going to go to stat. I'm going to go to t-stats. I'm going to go to one sample and with summary. And I'm going to enter in all the data that I need. The sample mean here was 3.95. The sample standard deviation is 0.67. The sample size is 86. And I want to conduct a hypothesis test where the mean was equal to 4. And our alternative hypothesis is not equal to. Remember, again, don't touch the confidence interval or anything else. Great. So now I've run my hypothesis test. And I have my test statistic is going to be negative 0.692. So it's going to be negative 0.69. Our test statistic is going to be 0.4908 or 0.491 if we round it to 3 decimal places. And then we want to state the final conclusion. So remember that in our flow chart, does the claim contain the condition of equality? Yes, it did. Did we reject the null? No, we failed to reject the null because remember that the p-value was way bigger than our alpha of 0.01. So we're going to fail to reject the null. So therefore, there's not sufficient evidence to warrant rejection of the claim, which means we actually kind of support it, right? So we're going to fail to reject the claim, and there is not sufficient evidence to warrant rejection to conclude that the claim that the mean of the population is equal to So there's not sufficient evidence to conclude that the original claim that the mean of the population of course evaluations is not correct. Okay, so this is where the double negative is a little bit tricky here, is that it's not sufficient to say that it's not correct, which means we kind of accept it. Let's look at a new example here. something that we'll do with the mean test is that we'll have a list of data that we'll actually use to do our test. And here we have lead concentrations in micrograms per gram per gallon measured in different traditional medicines. We're going to use a 0.1 significance level to test a claim that the mean lead concentrations for all such medicines is less than 17 micrograms per, it can't be gallon. It's got to be something different. I'm not exactly sure what the unit is, but we're talking about a concentration of lead. So assume that the lead concentrations are normally distributed. That's important. That because our sample size is less than 30. Great. So we're going to say that our null hypothesis is equal to 17, and our claim is that it's less than 17, which doesn't have the condition of equality, so therefore our alternative hypothesis is also going to be less than. So we're going to choose option C. Now we're going to determine the test statistic. So we're going to go to stat, we're going to go to t-stats, we're going to go to one sample with data this time. We're going to import the data and have it do all the heavy lifting for us. So now we want to click this little part here, and we're going to open it up in StatCrunch, or you could copy it to your clipboard. We're going to open it in StatCrunch. It'll bring up a whole new StatCrunch window, which I'm not signed into right now. So I'm going to copy it to a clipboard. So I'm going to do Control C, and then I'm going to go to this StatCrunch here. I'm going to do Control V. Doesn't really matter where you do it. Actually, I'll do. Then I'm going to go to your best option when you do this is to open it up in StatCrunch, because you'll already be signed into my StatLab. Because I'm just doing a video here, I'm not actually signed into my StatLab right now. So now I'm going to go to Stat. I'm going to go to T-Stats, one sample with data. My data is going to be in var1. I'm going to do a hypothesis test where my null is equal to 17 and my alternative is going to be less than. And this is all I have to do. I'm going to go ahead and click compute. And it's going to take the data that they have. It doesn't matter if I'm missing a few blanks. So now my test statistic is going to be negative 2.05. This means that it comes in negative 2 standard deviations below the mean. I want to type in my p-value. We're going to round it to 3 decimal places. That's going to be 0.035. And remember that p-value comes from this right here. Now my alpha that I'm using is 0.1. My p-value is going to be less than my alpha. So I'm going to reject the null. Great. So now my claim was that it was less than. So it didn't have that condition of equality. So if I go to my flowchart, does the claim contain the condition of equality? No. Did we reject the null? Yes, we did. So the sample data supports the claim. So there is sufficient evidence to conclude that the mean concentration for all such medicines is less than 17 micrograms per gallon, or whatever that unit is. Let's do one more. Or let's not. I think you guys have the understanding of this. Remember that when you're working on these things and you get stuck, you can always use help me solve this, view an example. But remember, when you use these two options, it's going to show you how to do it by hand and not how to use StatCrunch to make that happen. So I encourage you to come back to these videos that I provide for you to use StatCrunch. You can always use the Ask My Instructor feature that I'll send an email directly to me, and that will allow me to copy and paste things in StatCrunch that I can send to you. All right, good luck, and if you have any questions, send me an email, and good luck.